Hello everyone, my name is Yakubov,
And my name is Bakhmutov.
and in this video we're going to present you our thesis work. So the topic of our thesis is design and development of mobile fitness application, and the application made for the case company named Fit Technology. So first of all, I'm going to discuss the objectives of this thesis. So there are two main objectives in the research. The first objective of the research is to analyze different application development approaches. The most prospective and relevant tools and frameworks are reviewed and analyzed in order to specify their advantages and disadvantages over each other. And the second objective of the research is to design and develop a fitness training application with focus on usability and specifically a gym-resisting training application based on rational training model. About the application development approaches. For this thesis work, we have chosen the three most prospective ones. The first one is a native application development approach. The native code is a code that was originally written for a specific platform or set of devices with similar hardware or operating system. So the examples of native application languages are Objective-C or Swift for iOS platform or Java programming language for Android platform. So the main advantage of the native application approach is the best performance compared to other approaches. Basically, with native approach you can get as good graphic as you want with the best performance results. However, the native applications are platform restricted, therefore it's not possible to share a code among different platforms, and which results in the high cost of the development. So if the application is planning to target two platforms, the cost of development will rise by 2 times, which is not really good for medium applications. So second application development approach is a hybrid application development approach. The second application development approach is hybrid application development. Hybrid application development is a process of developing a web application using the standard web languages such as HTML, CSS, or JavaScript, and distributing the application as a standalone application through the application market. So the main advantage of the hybrid application development is the shared code base for all platforms. Basically, one code base can be compiled into different platforms applications, which saves a lot of time and saves a lot of money for development. But on the other hand, since the application is written using the web standards and running inside the native web view of the application, it shows rather low performance comparing to others, and it's not appropriate for complex applications. So there are several frameworks for hybrid application development, such as Apache Cordova, PhoneGap, or Ionic framework. And the final application development approach used in this thesis work is the cross-platform application development approach. The cross-platform application development uses one unified code base and compiles it into different platforms' native code. So its advantage is that the final application is similar, it shows a similar to native performance with a lower cost for development. Basically, it has the same principle of writing the one code base, which will be compiled into different platforms applications. But compared to hybrid application, the compiled code is not run in the browser of the device. It utilizes the device full features and is able to access all device features such as camera, contacts, geolocation, and other any features. And the cross-platform application development is usually written in one language. For example, it can be C# language for Xamarin Framework and JavaScript language for React Native Framework. And as a result, the cost of development is not so high as for native applications, but the result is close to native performance.
Properly prepare the development environment and identify all the priorities we have gathered the requirements. Requirements were primarily coming from the case company Fit Technology, meaning that the company and company directors gave us a list of features that they wanted to have in the application. Additionally, we have gathered an analysis of the target audience in order to prioritize these features according to the needs of the end user. According to the analysis, target audience primarily consists of gym professionals and experienced athletes, so that some of the features from the initial list of features were not that important. For example, explanation of all the features or introduction and basic tutorials were not done because they were not required and they were not needed by the target audience. As a result of such an analysis, we have created a prioritized list of features, a document which contains the order of execution for each functionality. The most important ones are marked in the high priority section. These include diary, programs, doing exercises inside of the program, list of exercises, and user performance statistics. Diary feature includes basic statistics gatherment that we have to display to user. Programs are contain exercises that were composed and designed by Ari Usitalo, who was the director and the initial original owner of the idea. And also it was important to have the list of features available in a separate section in the application. So we have also gathered the medium priority features that included notifications, exercises reordering, and different exercises management techniques, logging custom activities, gathering user-specific data, finding exercises alternative inside of the workout, and sharing in social media. And as it was identified before, some of the features were not needed and they were marked with a low priority and you can find them in the low priority section. So these were including primarily all the information that was done for user education, integration with external devices, integration with native applications, and for example printing the overview of the workout. The design of the application, we have used the most detailed guidelines available: Apple Human Interface Guidelines and Google Material Design. From both of these guidelines, we have taken the best practices and implemented them in the application. We have incorporated practices related to the typography, content hierarchy, and navigation and have successfully implemented all of these features in the application. The application makes use of three main navigation styles: flat navigation, which has resulted in the use of bottom tab navigation, which you can see on the screen slide. We have also used hierarchical navigation, which has helped us to elaborate each feature and still make the application simple. So according to Google Material Design, we have decided to deconstruct all the complex functionalities. For example, program functionality was considered to be a complex task for users, so we have deconstructed it according to the both Google Material Design deconstructure principle and hierarchical navigation principle from Apple Human Interface Guidelines. And also we have used event-driven navigation pattern, which has helped us to logically combine different states of user data in a more interactive and engaging form. So for example, if user has no program, we are displaying a call to action button which helps user to discover some program, and if user has already enrolled in some kind of a program, we are displaying all detailed information of this program with a shortcut way to enter this program and manage all the exercises, and also we are showing all the statistics available for user and gathered during the previous workouts. See all the other components and UI elements that we have implemented for the application. So some of them include the input of the workout data for user. So for example, on this element on the left side, you can see that it's an UI component that allows user to input repetitions and weight for each exercise and save all of them in one sequence. So we have also combined UI elements for statistics and for keeping track of records and some other elements. All of them were designed in a way that allowed us to keep the consistent use of all of the smaller parts, and in future we have successfully implemented them for the development of React Native components. To develop the application, we have used React Native and Expo XDE. Expo has allowed us to use its simplified environment for application distribution, debugging, And we have also made use of some built-in components like Facebook login or some asynchronous code management. Since we have used React Native, it was logical to divide application design into several components, since React Native depends on components fully and makes use of them. Basically, we have deconstructed the user interface into small and simple parts. The deconstruction allowed us to create consistent and context-independent components that we could use in any screen of the application. Additionally, we have created screens which are simply wrappers for the React Native components. On this slide, you can see the full list of the screens and components that we have created for the application. Since we have incorporated principle of encapsulation and code independency, it was possible for us to create rich combinations of screens and components. So instead of rewriting code all the times, we are just importing component from another file and using it. So this principle is resulted into the great application performance that is going to be described later.
For the testing of the application, we have used the Expo software development kit with the simulator of iPhone SE. So I'm gonna briefly show you the application and I'm gonna explain you and show the performance results of it. So first of all, the Expo XDE, the software development kit, which helps to run the application on the simulator and show all the logs or errors from it. And so the application is running now on the iPhone SE, running on the iOS 10.2 version. So now we can see the device itself and the home screen of a logged in user who already have done some exercises. So as you can see from the screen, it shows already statistics of exercises by day weeks, and you can also see the statistics for previous or next week. So additionally, it shows the average weight, total weight, and other statistics. And if the user wants to continue program, he can go here, and here he can see his program, and he can see all the exercises, how many sets and repetitions he need to do to do the program. So, and by clicking the continue program, he will enter the program itself, and he will start doing the program. So as you can see, it shows the exercise name, the muscle, the reps and weight that you have used. You can change the input and add as many sets as you want. Additionally, you can replace exercise with alternatives. So beside the programs, we have another main functionality called the exercises library. So exercises library is divided into the muscle groups, where under each muscle group you can find the specific exercises. So an example, under the triceps group we have two exercises, like cable push down and French curls. And each exercise have its own instructions, have the muscle group, and also have a learning video of how the exercise should have been done. So in the video the muscles are highlighted as well. So the third part of the application is a diary. In diary gives you some advices about the training. Additionally, from diary you can add a quick workout if you know what you have done in gym already, or you are doing the same program already 2 or 3 weeks. Additionally, in diary you can see all the logs that you had before. So for example, I can see the exercises that I have done previous days, and I can see the repetitions and kilograms I have used for that day. And the last type of our application is profile screen. In profile screen you can see the basic statistics, your current program, you can leave program if you want, and additionally you see the statistics about your training. So, and now I'm gonna open the performance monitor so you can see the application's performance. So as you can see, the UI elements and JavaScript compilation going under 60 frames per second. So currently application is taking 420 megabytes of RAM memory, operating memory, and you can see the amount of use. So as you can see, the application is quite stable and the amount of frames are not changing. Even if I'm going to the screens, it doesn't change much and it still produces the 60 frames per second performance. So as a result, the application currently have 4 different programs for users and 30 different exercises for training, and it's ready for market publishing. So application already have been tested by 20 different users, and most of them are gym trainers or regular gym visitors who have tested it and outlined some usability problems which have been already solved. And the application is planning to be published in year 2018, when the more content will be added and when the marketing plan of the application will be ready. So regarding the thesis work, all the objectives of the thesis work have been met, and since the constructive research method have been used, so the authors of the thesis have learned by experience of doing the application. So the thesis work contains the theoretical material and it contains a practical approach, and the outcome of the thesis work is a working mobile application which is ready for market